Hello, everyone. This is our new unit on rational functions. After studying polynomial functions, we're used to seeing functions that are very smooth when we graph them. And these ones are going to be a little bit more disjointed. They're going to have problems that are x values that you're not going to be able to plug in. And we call these domain restrictions. Domain restrictions are values that can't be plugged in. Values that make the denominator equal 0 are often common domain restrictions. So these rational functions are all going to be fractions. They're all going to have values of x in the denominator. Because you cannot divide by 0, there's going to be values of x that simply don't work. And just to understand why we can't divide by 0, you take any number, let's say, 10. Say, all right, well, what is 10 divided by 0? And a lot of times we think it's going to be 0, but really it's going to say undefined. We are not allowed to divide by 0. So what makes the denominator equal to 0 are going to be considered your domain restrictions in cases like these, okay? So all these problems, there's 4 examples. 2 of them are multiplication and 2 of them are division. Now the multiplication and division problems are essentially the same thing. Division just has one minor thing that makes them a little bit different. So let's start with example 1, and I'm going to work this out on a separate clean sheet of paper. And I would maybe recommend you do that first and then consolidate your work to here once you're done with it. So you have space. So example 1, you have x squared plus x minus 6 over x minus 5 multiplied by x squared minus 25 over x squared plus 4x plus 3. And our goal is two parts in this problem. We have to first list the numbers that don't work in our domain restrictions, and then we're going to write a simplified expression. And for our purposes, we have some answer choices here that can help us decide which expression is going to be equivalent to that. And we will use our Desmos graph to kind of match those up. So let's start with restrictions. What makes the denominator equal to 0? Okay, what makes our denominators being x minus 5 and x squared plus 4x plus 3. So we're going to start with this x minus 5, and we're going to set that equal to 0. And sometimes they're pretty easy to solve. In this case, you would just add 5 to both sides, and you would say x is equal to 5. So that means that our domain restriction is x is equal to 5. We say x cannot be 5 because really you're not allowed to plug in 5 into this function. If you did, you would have 5 minus 5, and that would be 0, and then you'd be dividing by 0. It doesn't matter what's over here. If you're dividing by 0, that's going to give you an error. So that's one of your restrictions. The other restriction comes from here. We have x squared plus 4x plus 3 equals 0. This is a factorable quadratic, and you can factor it. You can also maybe use your graph to find the zeros. We've done that before, so I'm okay with you doing that here. We can just simply do x squared plus 4x, just use Desmos. And you can see where it hits the x-axis. Let's zoom in on that a little bit. It's going to hit it at -3 and -1. So you can get your zeros from there. That does factor. So if you factor that, that's going to be two numbers that multiply to 3 would be 3 and 1. So x plus 3 and x plus 1. And they also add to 4. So if you set both of those factors equal to 0, and you subtract 3 and subtract 1 from each side, you're going to get -3 and -1. And remember what I said about restrictions. These are numbers that don't work. So restrictions don't work. You are not allowed to plug them in. If you plugged in -3 and -1 into that, it would give you 0, and you can't divide by 0. So your restrictions altogether would be +5, x cannot equal 5, x cannot equal -3, and x cannot equal -1. So when we talk about restrictions, we want to compare that to domain. Your domain is all the numbers that work. So your domain is all real numbers, because you can plug in anything else into this expression, except for the 3 numbers over here. So we say except +5, -3, and -1. So your domain gives you, your restrictions give you a domain. And I don't really think the order matters so much, but usually if it did, you would say -3 first, then -1, and +5. Those are your domain restrictions. So now let's go back into the second part of the problem was we wanted to simplify. So how does that simplify? Well, if you want to cheat, of course, if you have multiple choice answers, I can tell you what the answer would be. And then we can kind of go down and figure out how to do this the right way. So let's go ahead and start by just plugging it into the graph. You have a fraction times a fraction. So I'm going to pull up divide. Just go down here to divide, or you can press the slash bar on your keyboard. And then you would do times. And then you got another fraction, so another division. And let's input this in here very carefully. That graph is going to be x squared plus x minus 6 over x minus 5. The right side is going to be x squared minus 25 over x squared plus 4x plus 3. If you're doing this on your Chromebook or another computer with a keyboard, of course, using the Shift 6 key, use your keyboard shortcuts, it's a little bit faster. So we graph it and we get a good look at what this graph looks like. And of course, these are going to be very weirdly shaped graphs. So we'll learn more about why they're shaped like that in another lesson. But you get the graph shown, and then you want to test your answer choices into the next line. So I'm going to put all 4 in. I want to get a fraction for x plus 1. And I'm going to put that over x minus 2. And right away, you can see that that graph is not equivalent to the original one because it's not the same graph at all. So I'm going to leave it there, but let me put another slash here for this fraction at answer choice B. That'll be x minus 2, and that's going to go over x plus 1. And that produced a red graph on my picture, and that didn't match up with anything. So on to part C. Again, press the division. And looks like I need parentheses, so I'll have x minus 2 and then close it up. And a new set of parentheses would be x plus 5. And on the denominator, I will have x plus 1. Nothing new appeared, so it looks like it did highlight over my original problem, so that's likely to be the answer. Let me go ahead and just put the other one on here so you can see all of them. And I'll hide each problem. You can hide the graphs. Here, let me pull this down here. You can hide each graph, and I would hide all the ones but the original one. That way you can just look at one thing at a time. So I got my original function, I got my 4 answer choices. If there's 5, put all 5 in there. And you can just turn one on at a time. That doesn't overlap it, so let's take that off. Answer choice B, that doesn't overlap it. Answer choice C, it's the same thing. You can may not be able to tell, but the color did change on here from purple to blue. And answer choice D is something different too as well. So the answer is going to be choice C. So I have the answer. I didn't teach you how to do that, so let me do that now. So let's first, let me go on to my scrap paper so I can show you how to work that out. Now, if you're going to use your Desmos to get the answer, I'm not going to require this for every problem. Let's take my original problem. I'm going to rewrite that out. And I'll show you why it ends up being answer choice C. The first thing you must do on this problem is to be able to factor. So each expression, not everyone, this one's already factored. X minus 5 can't be factored anymore, but you can factor all the quadratic expressions. So that's going to be factorable. We can factor this. We can factor that as well. We actually already did factor this x squared plus 4x plus 3 when I showed you why it was -3 and -1 for the restrictions. So we already have that one, so I'm going to go ahead and write that. That's going to be x plus 1, x plus 3. So x squared plus x minus 6, you have to think about what two numbers multiply to -6 but add to positive 1. So they got to multiply to -6 and add to 1. Well, let's see, 6 is 1 and 6 or 2 and 3. And if I use 2 and 3, if one of them is negative, I can get them to add to 1 and multiply to -6. So it looks like it's going to be x minus 2 and x plus 3. Now if you go over to here, I have x squared minus 25. Notice that 25 you can take the square root and get a perfect a whole number. That's going to be 5. So this is a difference of squares factor. That's where one's plus and one's minus. So the square root of 25 is 5. So x minus 5 and x plus 5 would be your two factors for that. And of course, x minus 5 does not factor. So I'm just going to rewrite that. So I have all the stuff on the top and all the stuff on the bottom now. Everything's factored. I'm going to rewrite this. I'm going to write all my factors that are on both numerators together. You can think of this as one big fraction as opposed to two separate fractions. Once you got it all lined up, then you start canceling things out. So you have to cancel out pairs of things from the top and bottom. So you look at x minus 2. Does it have a matching x minus 2 on the denominator? It doesn't, so we're going to skip over to x plus 3. X plus 3 has a pair down here. So let's cross out. Does x minus 5 have a pair down there? And it does. So I have an x minus 5. Let me use blue here. Those cancel out. So this x plus 5 doesn't have a pair below it. The x plus 1 doesn't have a pair above it. The x minus 2 doesn't have a pair below it. I'm stuck with what's left here. X minus 2, x plus 5 on the numerator, and x plus 1 on the denominator. So what I'm going to do is I'm going to rewrite it just with those. And this would be my simplified answer. And if you look back over here, hopefully you can see the connection between my simplified answer and that answer. And why? Because the things canceled out, it ended up being equivalent to my original expression. So as you know, decide how you're going to write this in here or utilize your space. I am not in this example going to put all the work that I did on here. Let me leave this up just for a minute. If you want to pause the video or maybe recopy this so that you're able to fit it onto that example. That is fine. Okay. Now I'm going to ask that you do example 2. So remember, on example 2, you want to get your restrictions. And you want to get your simplified answer. And you can use your graph if you want to compare your original expression to answer choice A, B, C, D. So just click pause. Try it on your own. When you are ready, unpause it and check your work. Okay, if you've gotten a chance to try, and you can take your denominator and set your x squared minus 16 and your x squared plus 8x plus 16 equal to 0. Welcome to use Desmos if you want. You should get 2 answers for your restrictions, -4 and +4. So your domain will be all real numbers except -4 and 4. Now pause it again and try getting your simplified expression, either using graphs or factoring. Okay, I have the original problem and the 4 answers typed in. I turned off the graph. So I'm going to check one at a time. And this is the method I would advise you to do. So I'm going to turn on the first one. And it draws a different graph, as you can see up there. So answer choice A is not going to work. B is close, but it's still a little bit off. So I'm going to turn that one back off. C gives me a different graph. And D, look at D, turned my the graph that was black, it turned it red. And it looks like it overlapped it. So that's going to be my answer. So pause it again if you are interested in seeing the work to get to that. And I will put that work on there in a second. Try it on your own though. Okay, let's check the work. So I put it on a separate sheet of paper. You can see how I got the restrictions. Again, I just set my denominators equal to 0. You can factor or use Desmos to assist to get those values. Those are the zeros. So -4 and 4. Now, as far as my simplifying goes, I utilized my factors. On the denominator, I had x minus 4, x plus 4, it's difference of squares. The numerator on the first fraction had a GCF to take out, so that was just 2 on the outside, x minus 4 is left over. The numerator on the right side had what multiplies to +4 adds to 5, so 4 and 1. And the denominator, x plus 4, 4 is multiplied to 16 and add to 8. So if you look at rewriting all those to x minus 4, and then the x plus 4, x plus 1, and then down here I have the x minus 4, x plus 4, x plus 4, and x plus 4. And I can't cancel a ton out. I have a pair of x minus 4s that I can cancel. And I only have one pair of x plus 4s. If you have more than one thing on a side, you can't just get rid of all of them. You can only do like a matching pair. So I'm left with 2x plus 4s on the denominator, and this 2 and the x plus 1 on the numerator. We want to write the 2x plus 4s as x plus 4 squared. So that's how to do that by hand. Let's do example 3 together. Okay, so with the division problems, it's very similar, but there is a minor thing that can cause some people to get confused on the restrictions. So with the restrictions, I told you to set your denominators equal to 0. When you're dividing by a fraction, the denominator x squared plus x minus 12, that's the denominator. You have to set that equal to 0 to get your restrictions. But when you're dividing by stuff, everything you're dividing by has to be set equal to 0. Therefore, you have to set that and that both equal to 0 when you see division. Not with multiplication, but with division, because you're dividing by those, and you can't divide by 0. So that's how you get your restrictions. So we can do that here. Why don't you pause the video and try it on your own? And I'm just going to get you those restrictions right from Desmos. Okay, so if I'm getting the zeros from this denominator, if I turn that on, it looks like it's going to cross at -4 and +3. So my restrictions are for this one, x cannot equal -4 or +3. -4 and +3. All right, let me turn that one off. Let's do the x squared minus 1. And again, these can be done getting factors too. All right, your zeros for that are plus and minus 1. So that's going to come from over here. So that's you could write plus or minus 1 if you want, just to make that simplified. And over here, my restrictions are going to be at 0 and 3. X cannot equal 0 and 3. So let's look at all of my restrictions. I have -4, +3, 0 and 3. I don't want to repeat it, so 3 is going to be one of them. 0 and -1 and 1. So my restrictions x cannot equal, and let me go in numerical order. So I will say -4, -1, 0, 1, and 3, which means that in this division problem, I cannot plug in these 5 numbers. So my domain is all real numbers except those 5 numbers that we just listed. So -4, -1, 0, 1, and 3. All right, rewrite the problem out for the division, the simplifying part. Okay, I went ahead and rewrote it here to show my work a little bit later. Let's go ahead and get our answer though. So when you're doing a division problem, you want to be careful how you enter that in, especially in Desmos. You know, you're going to hit divided by to pull up a fraction. And if you go over to the right and you try to put divided by, what it's going to do is it's going to put a fraction below it. And that's not a problem, you just got to know how to enter that. So what I end up doing is, let me do that again so you can see. So I hit divided by, or hit the slash, I go to the right, then I hit divided by again, and it puts a fraction below it. Hit it a third time. So what you're going to want to display is a fraction on top of a fraction. Notice the middle line is a little bit wider than these two, and that's how it needs to look. So now we can input our expression in here. So let me pause that and input it. Okay, you're going to want to pause that so that you can type that in your Desmos, and take a minute to also look at my graph and make sure it lines up with the graph you have. Be very careful how you type that in. Okay, pause it and enter that in. I'm going to go ahead and put the answer choices in so we can match it up. Okay, I have all my answers in the next 4 lines. I'm going to go down the list and turn them on and see which one matches up my original function. So hopefully you've done the same and you can do this with me, or maybe you've already done it. Answer choice A is different. Answer choice B looks like that overlapped it. Let me try that again. Watch the color on it as I type it. Oops. There it is. Oops. All right, so it looks like it's going to be B. Here's C, different. And here's D, which is different. So our restrictions were gotten by getting the zeros from the denominator. And the answer is going to be answer choice B. Pause the video and I can show you the work to get that. When you're dividing a fraction, you got to be really careful with division, because dividing is different than multiplying. When you divide, you want to turn this into a multiplication. So you're going to do something that you might remember as keep, change, flip. What that means is you're going to keep the first fraction, you're going to change the middle sign instead of division, you're going to change it to multiplication. And you're going to flip the second fraction and make the numerator the denominator and vice versa. So we want to write this as x squared plus 5x plus 4 over x squared plus x minus 12, and then multiply it by x squared, 2x squared minus 6x over x squared minus 1. Once you do that, then it's exactly the same type of problem you're doing as multiplication. So why don't you try to factor and cancel stuff out, and we'll make sure that we get the same results in the end. Okay, above is the factors listed for each numerator and denominator. Everything has something you can factor out of it. In the case of the right numerator, it was just the GCF. All right, rewrite it and see if you can cancel out stuff, and we can make sure we get the right answer. Okay, when I rewrite it, I'm just putting it as one fraction. See what you can cancel out. All right, so a lot cancels out here. The pairs of x plus 4s go away. The x plus 1s from here and there go away. And the x minus 3s here and there go away. What I have left over on the numerator is 2x, and on the denominator is x minus 1. All right, I'm not going to explain the last one. I want you to try it on your own. I'll work it out and have the answers available for you so you can check them. And then you can continue on to your assignment. Your assignment is just, the backside has some problems on here, and you're going to submit those questions on Canvas as well so you can check your answers. All right, pause it, try number 4, and check with me. Okay, you can check the restrictions. You can remember this is division, so this bottom fraction is what's being divided. Remember, you want to do your denominators, but also the numerator on the right one too. So because it's division, because it's being divided. So x cannot be positive 1 because that makes this 0. This can factor to x plus 1 or x minus 1, or you can get them right from Desmos, get your zeros for x squared minus 1, and x cannot be negative 1 or 1. And for the numerator up here, x cannot be 3. So your domain is all real numbers except negative 1, 1, and 3. Okay, go ahead and pause it and try to work it out, or use your Desmos to find out a matching answer. Okay, so on this problem, the answer is C. If you were able to match that up in your graph, that's great. The work involved here, let me kind of explain just quickly, step by step. The original problem, I like to write as a division, not as two fractions, but when you type it in Desmos, you really have no option. I keep, change, flip, because you want to make that a flipped fraction so you can do times. I factor, this is a GCF, so 2 can be brought out of here, x minus 3. X minus 1 can't factor, x minus 3 can't factor, and x squared minus 1 factors to x plus 1 and x minus 1. Then I cancel out what I can. I have a pair of x minus 1s and a pair of x minus 3s. What I have left is, on the numerator, a 2 and an x plus 1. I don't got anything left on the bottom, so that's just going to be a 1. But when you divide by 1, it just doesn't have a number on the denominator. So it's going to be 2x plus 1. That's your lesson, and you're going to want to work on Unit 4, Day 1 assignment. That's going to be due tomorrow. Hopefully this was helpful. Thank you.